Hello everyone, plus 2 here. We are doing 2025 Scholarship Calculus question 3C. Before I start, I'd like to tell you why I'm doing this. I don't think I can make money out of this, but I really enjoy helping you guys solving these challenging questions. At the same time, I sharpen up my blade, meaning my skill sets. Awesome. Right, let's start. A local council wishes to supply internet to an island 30 kilometers from the mainland. One option involves running a cable between point A on the island and point B on the mainland, 40 kilometers further down the coast, as shown below. The cost to run a submarine cable under the water is $W per kilometer, and the cost to run an underground cable on the mainland is $L per kilometer, where W is greater than L. Use calculus to determine how the cable should be installed to minimize the overall cost of this option for two distinct scenarios. One is W is 1.5 L, the other one is W is 1.2 L. Right, so to install the cable, I would say something like this, right? So let's label the one under the water is Y and underground is X, right? So we have to find the relationship between X and Y, I believe. So Y in terms of X is what? You see, this is a right angle triangle, right? So we can tell like a Pythagoras theorem, the square root of 30 squared, which is 900, minus 40 take away x, isn't it? Squared, I mean, right? So that's y. So therefore C, the cost must be what? It says under the water is $W. So it's got to be YW plus under the land is $L. So it should be XL, isn't it? And then we have to differentiate to minimize the cost. However, we have too many variables here. So first of all, let's deal with this. So option 1, when W equals 1.5 L. So I'm gonna unify the variables in equation C. So instead of Y, I have to say square root of 900 minus 40 minus x squared, and then times by, I will say times by, instead of W, I will say 1.5 L, right? So once I finish this for 1.2 L plus XL, right? Oh, I'd rather say LX, okay? Because we are gonna differentiate in terms of X soon. So I can rewrite this square root with the index. So that's, and at the same time, I'm gonna expand. So that's bracket 900 plus 40 squared is 1,600. Sorry, why do I say minus? I made a mistake here. Pythagoras theorem is a plus, isn't it? Yeah. So 1,600 minus 80x plus x squared to the power of half, isn't it? Right? And then times by 1.5 L plus Lx. Okay, I think we are ready to differentiate. So what's dc dx? So well, 1.5 L stays the same, but half the index comes front. So half of 1.5 is 0.75 L, and differentiate outer. So by the way, it's 2,500. So x squared minus 8x plus 2,500 to the power of minus half, isn't it? Half take away 1. And then times by inner, meaning derivative of this, which is 2x minus 80. And then plus L, isn't it? When you differentiate Lx, you get L. So if I rewrite this, 0.75 L over square root of x squared minus 80x plus 2,500. Well, I do have this. By the way, if I factorize by 2, 2.2 times 0.75 becomes 1.5. And then I will say x minus 40 looks better. And then plus L, then, isn't it? And as you know, we have to minimize this, so equals 0. So I assume this is a local minimum, right? So if I rewrite this 1.5 L x minus 40 over this equals negative L, so it's minus L square root of x squared minus 80x plus 2,500, right? First of all, I can get rid of L, and then I square it to get rid of square root. So that is 1.5 squared is 2.25, and it goes x minus 40 squared equals, simply get rid of square root, right? So x squared minus 80x plus 2,500. So now when I expand and multiply by 2.25, it becomes 2.25 x squared minus 80x times 2.25 gives me 180x, and then 1,600 times 2.25 is 3,600, and right hand side is the same, and we are gonna simplify. So when we rearrange this, I have 1.25 x squared minus 100x plus 1,100 equals 0. Okay, so well, you could, I don't think you can factorize it. So use graphics calculator, or if you don't have one, just use the quadratic formula or completing the square method. So you will have x equals 66.83 or 13.17 kilometers. Okay. Now think about it. Can x be 66.83? No way, isn't it? The maximum distance on the mainland is 40. So this is not possible. So 13.17 kilometer must be the answer. Okay. So when x is 13.17, if you plug that into this equation, then y becomes 40.249, let's round up to 2 decimal places, 25 kilometers, right? So when x is 13.17 kilometers, y equals 40.25 kilometers. So this is under the water, isn't it? So that way you can minimize the cost. So now I will do second option. So W equals 1.2 L. So it is tedious because it's exactly the same process, but you just plug 1.2. So I'm gonna just skip some process. So obviously you have to find the C. You found the equation. So I will write that down. C equals 1.2 L x squared minus 80x plus 2500 to the power of half plus Lx. Okay. Then you differentiate C in terms of x like just before. So that becomes 1.2 L x minus 40. Is it? Hold on. Yeah, just 40. That's right. Over square root of x squared minus 80x plus 2500 plus L equals 0. So the same process, and you find quadratic equation like this: 143x squared minus 11,440x minus 196. So when you use a calculator, use calculator to find x, you will have x equals 80 or minus 0.017. Both are wrong answer, right? It can't be. So hence there is no answer for y. I believe. Yeah, it can't be. Okay, because x can't be 80, neither negative number. So, well, we don't have to check. So, the answer is this. So when x is 13.17 kilometers, y under the water should be 40.25 kilometers. So that should be the answer. Okay, cool. All right, then I will see you next time. Bye.